back down to business here. Okay, here we go. You all ready? All right, so I put a bunch of stuff here on the board. So today we're going to talk about the derivative, and then we're finally going to get into some things that have to do with business. All right, we're going to talk about what's called marginal profit, marginal cost, marginal revenue. All right, so those are finally some terms that might seem like you're in a business math class. All right. The derivative of a function. So here's the definition, and none of this should look new to you. All right. We are going to define it. If somebody gives you a function, okay, so let's say I give you a function x squared minus 4x plus 5, whatever, I give you a function, then we define the derivative of that function as follows. So this should look familiar. That's the difference quotient, right? And then all we're going to do is after we take the difference quotient, we're going to take the limit as h goes to 0. Whatever we get as an answer here, we call the derivative of the function f. All right, we call it the derivative of f of x. Now here's the way that we will write it. Okay, so this is a special new symbol that we're going to use whenever I want you to calculate this limit. I'll put f, but then I'll put this little prime mark. Okay, we call that prime, and we would say this f prime of x. So anytime you see f prime of x, this is what you have to do. Understand? Remember that geometrically, what this derivative represents, whatever we get here, whatever this answer is going to represent the slope of this line that hits the graph at exactly 1 point, at some value x. So I'm going to give you a function now. We're going to calculate the derivative, and then I'm going to ask us to find the slope of the tangent line at certain points. Does that kind of make sense? Okay. I'll give you a second to copy this down, and then we'll get started on a problem. Yes, what? Oh, I'm in the way. Story of my life. I'll take that out of the way, sorry about that. All right, I think that's enough time. It's on video if you need to go back and look at this. All right, so here's the first example. Let the function f of x be equal to 2x squared plus 8. Part A, find f prime of x. Part B, find f prime of 2. C, find f prime of negative 3. So we're going to do 3 different things for this problem. All right, so for part A, what do I need to do part A?
Plug in 2x squared plus 8.
Okay, so I'm going to be using the formula, right? Here's our formula. But now that somebody has given us the exact function to work with, I can now replace this piece and this piece with something else, right? So to plug x plus h into this function means I replace the x right here with x plus h, right? So my next line will be limit h goes to 0. Then I'm going to put what? What do I write next? 2, and then parentheses, x plus h, right? That's what I'm plugging in for x, squared plus 8. That right there is that piece right there, right? That's what it means to plug x plus h into that function. Then I will subtract from that. And that subtraction is this subtraction right here, f of x. Now what's f of x?
2x.
It's just this, right? You don't have to do anything. It's just that. So I'm going to put 2x plus 8. 2x squared plus 8. Now, is that correct? Or am I messing up there? I'm messing something up here. I need this in parentheses. Because we're subtracting the entire function, right? So that means the negative sign will have to distribute. Now, all of that gets divided by h. So this piece right here is that right there, right? Now we get to do some algebra. We actually have to figure out what this is. We need to distribute the negative sign through. And we've done this, right? We've done this. You took some problems home. You worked on some things like this. Done several examples in class. There's a lot of room for error here, right? The algebra. So if I'm going to do this, what should I work on first here? If I'm going to try and figure out what this is. The x plus h squared. I need to do that first. Now be real careful with that because x plus h, I'm going to do it like scratch work over here on the side. X plus h squared means x plus h times x plus h, right? That's what that means?
Yeah.
You do not just square each one.
So x squared,
So
2xh.
x squared, and then you'll have xh again. Ooh, whoa, what happened? So you're going to get xh twice. Bless you. And then the last one you'll get h squared. And then you combine those middle like terms together,
Yeah.
and that's where you'll get x squared plus 2xh plus h squared. So I kind of did that on the side, okay? That way I didn't mess that up. And that's going to just be this piece right here. I still have sitting in front of that a 2, don't I? So this is going to be limit h goes to 0, 2, then in parentheses x squared plus 2xh plus h squared. That takes care of this part. I still have plus 8, and then minus 2x squared minus 8, so that's this part. I pass that negative sign through, right? And then all over h. Notice how I'm writing this down. I wrote down the definition of the derivative. I replaced everything, right? Equals, limit. I'm doing everything nice and clean from line to line, right? I would try to help you get good at this. Make sure your thoughts are very clear from one line to the next. Don't just be doing a bunch of chicken scratch stuff. Keep your ideas organized here. All right, what should I do now? Distribute the 2. Okay, so I'm going to pass this 2 through the parentheses. And I told you all a long time ago when we're dealing with difference quotient that if you do it correctly, then when you're done with everything on top, you should have an h in each term. Let's see if that happens. I get a 2x squared plus a 4xh plus a 2h squared plus an 8 minus a 2x squared minus an 8 all over h. Still okay there? And does anything go away? Do we get anything that cancels here?
Yeah, 2x squared and
2x squareds and the 8s. And lo and behold, everything that's left has an h in it, right? So I'll leave this because those are the parts B and C that we still need to do. So over here, I'm still continuing. Equals, limit, h goes to 0. On top, we have 4xh. We have plus 2h squared. And that's it, right? On top, all over h. everything in the numerator, the top, has an h, right? So I can factor an h out of the top. Look at me. I'm writing limit again, right? I've had to write the limit each time. Just continue writing it. Pull the h out. You're left with 4x plus 2h all over h. And now you see those h's cancel, right? This h right here cancels out with that one. And we are to almost our last step. I'm writing the limit one last time. 4x plus 2h. Would you agree that everything I've done up to this point, we've done? Yes? The only thing different is that I'm carrying this limit in front the whole time, right? The whole time I've been writing limit, 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 limit. And now that I'm at the last step, now I'm going to let h go to 0. What happens if I let h go to 0 right now?
You end up with just 4x.
You just have 4x left, right? If that h turns into a 0, this goes away, and all you have left is the 4x. So at the end of it all, we have 4x is our answer. The derivative of the function 2x squared plus 8 is 4x. All right? That's the derivative. All right?
So the reason why you set h to 0 is because we wouldn't go in.
The limit says let h go to 0. And if you're trying to remember what this is about, this was about a curve with 2 points. We were trying to pull that point on top of the other one. And to do that, we let the h go to 0. Okay, we kind of slid that point over. So what we've done is we've figured out, it's like, hey, this is going to give us the slope of the line between 2 points the whole time. And then when we get to the very end, we say, okay, now slide the point over. And when we slide it over, it kills this off, and that's all that's left. Okay. The key to the problem, though, and this is what makes this work, is that if I go back up here to the very first line that I wrote, right here, if right here you try and let h go to 0, right here, if you try it right here, what happens is that goes to 0. Do you agree? Yeah. Okay, if that goes to 0, then isn't this 2x squared plus 8 minus 2x squared plus 8? And wouldn't you get 0 on top? And on the bottom, if I let h go to 0, I would get 0 on the bottom. And I get 0 over 0, which is undefined. But we said that that's bad. And there's a way around the bad situation, but we have to do the algebra first. If we do the algebra, notice that we're able to get the h's to cancel, and that kind of eliminates that 0 over 0. And that's what the whole idea behind this calculus is we avoid the 0 over 0 by doing the algebra first. Okay, let's get to part B. What do we need to do for part B? That's the answer to part A. Yeah, so for part B, we're asked to find what's f prime of 2, right? So what happens if we take that function right there, 4x, and we just plug 2 in? What do we get? 8. All right. How about part C? What's f prime of negative 3?
So once we find the first, once we find x, h equal to 0, is that h x, or what you say?
Once you drop h to 0, all you have to do is plug in the other number. It doesn't work. Okay.
Yep.
So we get, in order to find the entire answer.
We have found the derivative.
Derivative.
We have found the derivative of the function. This derivative holds for any value we plug in for x now. So we only have to do this one time, and now we can find the derivative at any point. All right?
Sure. So once we,
Okay.
So that's called the derivative.
This is called the derivative. Now look, geometrically, here's what's happened. If you go back to what you may have learned in 1324, if you were to graph this, this is a parabola. It opens up, and that plus 8 right there moves the whole graph up 8. So the graph actually looks like this. Here's 8, and it looks like this little, like a U, like this, okay? What we have said in part B, right here, is that if you go out to 2 on the x-axis, and you go up to the function, and you draw the tangent line, the slope of that line is going to be what? The slope of that line is 8. Now, if you go to negative 3, right here and go up and draw the tangent line. Hey, look, it's pitched down the other way, right? That has a negative slope, and the slope is exactly negative 12. Just by looking at that graph, what would the slope of the tangent line be at 0? If I went to 0, went up to the graph and told you to draw a tangent line, what would that slope be? It would be like this, right? It would be 0. Agreed? So it looks like just from looking that f prime of 0 should be 0, right? Well, is it? We have a formula, don't we? If we plug 0 into this, what do we get? 0. So it matches with what we're seeing on the graph. Make sense? Okay. All right, so now let's do a different example. And when I do a different example, the only thing I'm going to change is f, right? That's the only thing that's going to change. We're going to still go through the exact same process with a different function. So let's let this next example, I'm even going to ask you the exact same 2 questions, all right? Or 3 questions. All right, so new function, but part A is still the same setup. We're still going to do f prime of x equals limit h goes to 0, f of x plus h minus f of x all over h. Now, I'm not real big on memorizing things. Like, you know, as a student, I wasn't a very good memorizer. But this equation right here, this formula is so important. I do want you to just have that burned in, right? You saw it in 1324, and you've seen it now here in 1325, and we keep using it. So you need to remember this, all right? All right, so that's the generic formula for the derivative. And I'm going to give you about, I don't know, let's just say about 5 minutes to see how far you can take it on your own. Or you can work together, it doesn't matter. I want to see in 5 minutes how far you can get this, all right? If you have a question, you can raise your hand. I'll come by and help. Is everyone here okay? Any questions? I'll be right there, sir. Okay, so this part right here? Okay, so I like what you've done here. You just minus sign, put that in parentheses, you're good. Now you're going to be plugging x plus h into this. Okay? So replace that x with x plus h. Just write it down up here just so I can see you do it first. Parentheses, squared. And then you have, what is that? Plus 4, right?
Plug this into this.
And then this into that x also. So plus 4, parentheses, x plus h. And then minus 7. Okay. That's going to go here, right? Now, if you want, you can just like figure out what this is right now. Like you have to do like a FOIL on that, like multiply times itself, and then you have to distribute a 4 through. All of that will go here. Distribute your minus sign through. Yes? And don't forget to put limit out in front. Okay. Yep, this looks good.
that again, right?
Yep, you're going to do that here. Now, be careful because you wrote this right here, but you're still missing, you're missing this piece. So minus, and then in parentheses, just that function.
Which one? This?
Yeah, the original, because isn't this f of x? And you're supposed to be subtracting f of x. So you're going to put it there, okay? Yes? So hold on, let me talk to both of y'all at the same time, because it looks like y'all are both like in the same spot here. Okay, so what does f of x plus h mean? It means take x plus h and plug it in here and here. Okay, so I want you to write that down. Start with this one. You're going to go x plus h, and then in parentheses, squared, yep, and then plus 4 x plus h, right, minus 7. Okay, good. You agree that that's this?
Yes.
Okay, minus now, so put minus. And now in parentheses, f of x, which is just this with nothing, just the way it appears there. X squared plus 4x minus 7. Close your parentheses. Put all of that over h. And now you have to go through and you have to square that, so you might want to do that on the side. You'll distribute that through. You'll distribute the minus through, and then you start cleaning up.
Okay.
Did you get that top left now? You understand that? Okay, good. Question or? That's a 4h minus 7. And then you're supposed to have a minus here. There's a minus, right? It's minus f of x. So put minus and then put this all in parentheses. That's going to change all these signs. Okay? And then all over h. How are we doing here?
Pretty good.
Negative 2?
I think we got it.
Oh, that's your no, for the answer you got 2x plus 4. That's right.
Yeah, okay.
So everything else should work out. Good. How are you doing, sir? So you're good here. You're good here. You're good here. The minus sign has to go to each one of these. So it's going to be minus, minus, plus. And then put all that over h.
So I'll click here.
Yep.
So I already plugged it all in. But then there's nothing to distribute here, so you just do,
You just square it.
so x squared plus h squared.
Nope, you have to do them both in parentheses. I'll do it on the side. Come over here and write x plus h in parentheses. And then put it in parentheses. And then x plus h again in parentheses. Hold on just a second. And then you'll have to do like a FOIL.
Okay, so
Okay.
so it'll be x squared.
Mm-hmm.
Xh,
Yep, plus xh. Plus,
hx,
uh-huh. And then last one.
plus
There you go. Now these two are the same. H squared. You can put h squared.
oh, yeah.
And then now put these two together because those are the same thing. So put x squared plus 2xh,
2h,
2xh, or hx. It doesn't matter. I would just put 2xh. And then plus h squared. That is just this. Okay? Now I noticed when you plugged in x plus h, right? You're plugging in x plus h in this. You plugged it in here, but I don't think you plugged it in here. This should be right here, plus 4x8, x plus h in parentheses. I'm going to write it up on the board so you can see what I'm saying. Did you have a question? 2x plus 4? That's right. Okay. 2x plus 4? Good. You should be getting 2x plus 4. Okay, I'm gonna just put everything in here real quick so you can see it. Plugging in x plus h squared. I know I didn't get around to everyone, but next time I will walk around the opposite direction. So that's what happens at the top. Plug in x plus h in here and here. See that? Here and here, both spots. Then you have to expand that. So you do that on the side. We've already done that. It's x squared plus 2xh plus h squared. So that's just this squared. And then we have to distribute the 4 through. 4x plus 4h. And then minus 7. Then we distribute the minus sign through here. That's very important. I saw a lot of people miss that part. Minus x squared minus 4x plus 7 is what happens there. All over h. And now a bunch of things should cancel. You should get x squareds to go, the 4x's go, and the 7's go. And like I said, everything you should have left should have an h in it. If you've got stuff that doesn't have an h, then what does that tell you? You did something wrong. I'm going to continue that over here. Limit, h goes to 0, and I've got 2xh plus h squared plus 4h, and that's it on top, and then all over h. So notice my top, everything has at least one h in it. Then I factor an h out of the top. I'm left with 2x plus h plus 4 all over h. H's cancel. That's what we wanted. We wanted those h's to cancel. And now at this point, you can write it again on the next line if you want, or you can just take the limit, but I'll write it on the next line. I have not let h go to 0 yet. It's about to happen. So at this point, I'm going to let h go to 0. And so I no longer write the limit. If h becomes 0 here, then you get 2x plus 4. There you go. The derivative of this function is 2x plus 4. What was the derivative of the function we had before? 4x, right? The derivative of this function is 2x plus 4. Okay, different. We're getting a different result. So to answer parts B and C, all we need to do is plug in those numbers into this answer right here. So for part B, f prime of 2 is 2 times 2 plus 4, that's 8. Is that the same answer we got last time? Yep. It's just a coincidence, all right? Part C, f prime of negative 3. Now, if this comes out to be negative 12, I'll be shocked, but it's not. 2 times negative 3 plus 4, get negative 2. All right. What's that? Yeah, you multiply here first, negative 6 plus 4. All right, what do y'all think? A little bit of practice on that?
Yeah, just make sure we do the h plus 0 because we put h1.
Yep.
So,
All right, so let's see if we can't apply this to a problem that is somewhat business related, all right? I'm going to do a problem out of the book. Yep. All right, so we're going to be talking about profit here. And maybe before I get into profit, we should talk a little bit from 1324. In 1324, we have these ideas of profit, cost, and revenue. You remember hearing those? What is the relationship between those three? There's a relationship between them. There's an equation that relates those three together.
Revenue minus cost equals profit.
What's that?
Revenue minus cost equals profit.
Okay, so profit,
Profit equals backwards.
yeah, equals revenue minus cost. That's the big daddy right there, okay? If you like it written a different way, P equals R minus C. You'll see me write it that way a lot. So let's consider what that equation means, because that's like the, you all right? That's like the most fundamental equation that we have in any business model. Your revenue, see, people misunderstand the difference between revenue and profit, okay? Let's say that I'm selling, okay, well, I don't have a chocolate bar. Let's say I'm selling these teas, right? Okay, I did not. So I'm selling these, right? My revenue is the amount of money that I bring in from selling things. So if I go out and I have 10 of these, and I sell all 10 for $2, I brought in $20, right? So that would be my revenue. Now, I didn't tell anyone, but I went to HEB and I bought each of these for $1. Okay? So I spent $10 buying these, right? That would be my cost. My profit is the difference between the two. It's how much money I bring in. So this is the money in, this is the money out, this is the money left over. Okay? So your profit is not the amount of money that you bring in, it's the amount of money you bring in after you take into account the costs. Now, this would be, think about phones, right? So you've got your phone, right? These companies, Apple, Samsung, whatever, LG, all these companies that make phones, right? They have a certain price that they sell them for, which would be your purchase price, right? The money that they bring in from selling all the phones is their revenue, right? But it costs money to make phones, right? They have to buy the materials, they have to hire laborers to assemble the phones, right? That's their cost. So the profit is the difference between the two. And what we're going to be investigating in this class in more detail is how you don't necessarily get more profit from just increasing your revenue stream. Sometimes you need to bring down the price on the actual item to make more profit, which doesn't make sense. But sometimes that's what you have to do. It all depends on what's going on within the algebraic function that you're using to model your business. So if for some reason the function tells you, hey, look, you need to bring the price back in order for us to maximize profit, then that's what we have to do. So you'll see how it all works together, but I want to make sure you understand this relationship before we move forward. So what we're going to do right now is we're going to just look at a profit function. All right, so here's a profit function. We're going to call it P of X. So we're using capital P instead of F, right? This profit function is the function 45x minus, now we're going to start using some decimals, so you all are all going to freak out because I'm using decimals instead of nice numbers. All right. Make sure I wrote that down. Okay, this right here represents the profit in dollars from the sale of X infant car seats. So this is a particular company that manufactures car seats for little kids, right? And they have had their little financial person that has put together this model for them. They probably pay too much for this employee to come up with this, but they've got some really bright mathematician on their payroll that finds the equation to model their profit. There it is, all right? And there are ways to come up with this function, all right? There are ways to do it. It's beyond the scope of this class, but let's assume that we have it. This will give us the profit if we sell X car seats, all right? Profit. So this profit is already taking into account cost and revenue. Y'all understand that? This is the overall money that we are going to put in our pockets, right? After we pay our employees, everything, right? So this profit function is this. Now, we do have some restrictions. The restrictions are that X must be between 0 and 2,400. This means that our company has a restriction on how many car seats we can actually sell. And that's probably based on the fact that we can only produce so many, right? I mean, you can only produce so many iPhones or whatever, right, in any given period of time. So our restriction is that we're either going to sell no car seats, the most we could sell would be 2,400 car seats, or anything in between. Okay? With me? All right. Now, some questions. First question. what is profit if we sell $800 car seats? I'm just going to say seats. So who wants to volunteer and tell me what it is that they're asking for?
What is the cost and what is the revenue?
How much money is left over after you sell?
Okay, so this profit it will represent how much money we actually have after we sell 800 car seats. But how do I actually compute that? Like, what is that question asking me to do? Just plug 800 into the profit function, right? Yep, that's it. That's what that question is asking. It's saying, what's the profit if we sell 800 seats? We just plug 800 in, right? Because that's our profit function. So the answer to this is P of 800. Now, you might need your calculator for this. So the computation I'm about to do on my calculator is 45 times 800, and then minus 0.025 times 800 squared minus 5,000. Now be real careful with this part right here. You must square the 800 before you multiply times the 0.025. All right? Because order of operations, right? So I'm gonna go slow through this. Times 800. This is 36,000 up front here. Minus 16,000 here. So I squared this, and then I multiplied times 0.025, and I got 16,000. You should make sure that you can get the same thing on your calculator, and if you can't, you should probably talk to me after class. All right, and then minus 5,000. So what is this? $15,000. $15,000, right? Because this profit is in dollars, right? So if this company sells 800 car seats, the profit will be $15,000. Make sense? All right, next question. Notice I haven't asked any questions that involve limits or anything yet, right? Haven't asked for the derivative or anything else. Just, hey, what's the value of the function at 800? So part B, I think I'll erase this. Part B is going to be, what is profit if sales, or if we sell 850 car seats? So you're sitting there in the room with the other big wigs at the company, and you're like, okay, well, if we sell 800 car seats, we're going to make 15,000. What would our profit be if we sell 850? Maybe more. Let's see. I don't know. It depends on the model. It's not guaranteed to be more. So you just plug in again, right? This is just P of 850. So I think I'm going to do this all at one time on my calculator. Somebody want to tell me what they got?
15,187.50 cents.
Yep, 15,187 and 0.5. So I'm going to go 0.50 because this is dollars. So 15,187.5. Okay? So what this is telling us is this. If we sell 800 car seats, we're going to make 15,000. If we sell 50 more, right, car seats, our profit will go up by how much? $187. Right? $187.50. Yes? Okay. So geometrically, here's what it looks like. At 800 car seats sold, we made $15,000. Do you agree with that? And at 850 car seats sold, we made a little bit more, right? Whatever that is, 15,187.5, blah, blah. So what we have found is, like, we could connect those 2 points with the line, right? And that would be like this distance right here divided by this distance here would give us the slope of that line, wouldn't it? But there's a graph. There's a graph, see, because this is a function, right? So there's some graph sitting here. It's a parabola. And it goes like this. All right? What we're going to do now is we're going to ask ourselves this. What if we just find the derivative of the function right here at 800? Would that give us an answer that would be close to 187.5? See, because if we change our sales by 50, our profit goes up 187, yes? But maybe this slope of this tangent line would also give us a number close to this 187. We'll see. We're about to find out. So part C, I want to know what f prime of x is. That's part C.
I understand that. Why would we need to find out what if we already know what we have to find it if we have an equation?
Can you restate your question? What?
Why would we need to find the prime?
Why would we need to find the derivative if we just did this? Okay, because remember how in the previous 2 examples, once we found the derivative, then we could figure out what the slope of tangent was at any point. You just plug in 2, plug in -3, plug it in, whatever number you want, just plug it in. Well, the derivative works the same way. Once we get an answer, then I can go anywhere on the graph I want and figure out the slope of the line quickly. Because if someone wants you to go back and talk about what's happening between, let's say, 700 car seats and 750, you would have to go and recalculate that every time, right? Each time you want to move around the graph, you would have to recalculate the 2 things we just calculated. So the derivative gives us a way of doing one calculation one time, and then we can use it for the entire graph. Let's do it, and then you'll see what I mean, hopefully. Okay, p prime of x. This means we are taking the limit as h goes to 0. Now watch what I do here. P of x plus h minus p of x all over h. You see the difference in this one? I'm using capital P because I'm talking about the profit function. I'm not talking about the f function anymore. But it's the same formula. Now things are going to get a little messy now because we've got decimals in here. Do you all agree that's going to get kind of messy? Okay, so because of that, I'm going to kind of clear my board here. Y'all remember those numbers we had for parts A and B. All right, so that equals, all right, limit h goes to 0. I'm going to replace every x I see with what? X plus h. So 45 times x plus h minus 0.025 times x plus h squared minus 5,000. Then minus parentheses 45x. Yep. I got to erase this. X squared minus 5,000. And then all of that over h. I admit it, that's a mess. I mean, it's the way it is, though. Okay, limit h goes to 0. All right, the good news is on this first one, I can just distribute 45 through. So that's just going to be 45x plus 45h minus 0.025. And now this very common thing, we've seen this several times now, right? X plus h squared. And like since we've done it a few times, we know that it turns out to be x squared plus 2xh plus h squared. So just keep in mind, this piece right here is just that thing squared, right? Then I have minus 5,000. Then this negative has to go through. So what would happen if I pass that negative through?
Plus 45x, cancel each other out.
Okay, so that's going to be our minus 45x, and then plus 0.025x squared, and then plus or minus 5,000?
Plus.
Plus 5,000. I'm just the messenger, okay? This is the way it is. I mean, yeah, I mean, this is the way the math turns out, all right? Now, yes, I do agree some things cancel, but before I cancel them, I do need to distribute this through here and here. So we're going to get some decimals here, and it's not going to be real pretty, but it's the way it is. Limit, h goes to 0. Now here we go. I've got 45x plus 45h. And then this first multiplication of this times x squared should just be negative 0.025x squared. Now what about the second multiplication? This one times 2. It's going to come out to be minus 0.05. xh, right? xh. So if you double that number, you get negative 0.05, and that's where that comes from. And then what about the last multiplication to the h squared? Minus 0.025 h squared, right? Then you have minus 5,000 minus 45x plus 0.025x squared plus 5,000 it's a pretty long division bar all over h, and now we're going to get a bunch of stuff to go away. 45x minus 45x. This one right here with the x squared on it, and this one right here with the x squared on it. The 5,000s, where is it? There it is. Anything else? We'll pull the h out, right? But everything else that's left has an h. So I'm feeling pretty good about that at least. Come back up here. All right, so I have 45h. I have minus 0.05 xh minus 0.025 h squared, and then all over h. And then factor an h out. I'm going to skip that step. I'm just going to write down the result. So if I pull an h out of everything and cancel it, I'll be left with just what?
45.
45 minus
0.05x.
0.05x because the h came out.
Yeah, we already moved h to 0 because that would cancel.
No, we haven't moved h to 0 yet.
Put the 0.025h.
And we still have one h there. Okay, so that's one h coming out of the top, canceling with the bottom. Now, you asked, had I let the h go to 0 yet? And the fact that I have it written out here still means I haven't. Okay? So now at this point, I think I'm ready. Last step is to actually let h go to 0. And it's going to kill this one off completely. And so all I'm left with is 45 minus 0.05x. There it is. All right. Now, I do agree that that was a lot of work, okay, to get to that. And there's plenty of room for error here. As soon as we talk about a few more examples, I'm going to give you a shortcut to take the derivative without ever having to do the limit again. All right? So I have good news coming down the road. There is a shortcut. All right? But you have to see this and do it a few times before you get the shortcut. All right, here we go. That was part C, right? Now let me ask you part D. Find P prime of 800. So that just means plug 800 into that. You get 5? 45 minus 0.05 times 800. And you got what? 5? Oh. All right, we got 5. Well, I'm being told we got 5. Do you all agree? It's 5? Okay. What was the answer we got when I said, hey, what was the profit at 800? We said 15,000? And he said at 850 it was $187 more or something like that. And then I'm getting an answer of 5. What? It's the slope of the line, but what the heck's going on? It's not even close to 187, is it? So let me try and illustrate what's going on here. Because you might be saying, why in the heck go through all that work for that number if it doesn't seem to be close to the 187 we had? Remember, at 800 we were at 15,000, right? And then at 850, I'm going to exaggerate this a little bit. We're up here at 15,187.5. Is that correct? Yes? All right. So I said we have a curve that goes through here. And we just found that the slope of the tangent line through that curve is what? What's the slope of this line right here? 5, right? That's what we found. Okay, so here's what I'd like for you to consider now. Because I am going to make this make sense, I hope, as to why this 5 is actually important, how it's related to this $187 difference. Would you agree that if I draw a triangle like this, that the difference between here and here is 187.5, right? So this side is 187.5. I'll put 0 since it's money. Okay, now what is this distance from here to here? 50. Do you agree? So what is the slope of this triangular line right here, this green one? What is the slope of that one? Isn't it rise over run? So what is this number divided by this number? Someone do that for me. 3.75. 3.75? So asking the question, sitting down in the boardroom with the other employees and saying, hey, look, what's the difference in our profit if we sell 800 to 850? The answer would be, well, about $3.75 per car seat. For every car seat more that we sell, we bring in another $3.75. So if we sell 50 more of them, we're going to bring in 187, right? But what does 5 mean? This is the key to it all. Like, if I'm sitting down in the boardroom and I say, hey, but the derivative at 800 is 5, what does that mean? It's an instantaneous rate. It's actually the rate that we're selling, the rate that we're bringing in money, the profit. It's the rate at which the profit is changing at exactly 800 car seats. So as a company, I'm going to say, hey, look, the derivative at 800 is 5. I am happy to see that number because it's positive. Because positive means that our profit's going up, right? If this turned out to be negative 5, then we would know, crap, we're actually losing, right? We're actually starting to decrease our profit. So then the next question might be, all right, well then what's the profit What's the derivative at 850? So we would plug 850 into this derivative, whereas derivative's not up here anymore. 45 minus 0.05 times 850. Someone can do that for me. What do you get? 2.5? Yes? 2.5. So what does that tell you?
That it's going down.
So we still have, our profit is still going up, right? Agreed? The profit is still going up. But look, at 800, it was going up even faster, wasn't it? Did y'all see that? This is a way of measuring how rapidly your profit function is changing at specific values of sales, as opposed to the old kind of way of looking at things where you always had to look at two different values and compare them. Here we can always just look at a single value, look at this slope, and that somehow tells us, whether or not we're happy or not as happy or really upset we need to fire a few employees because our profit's going down. You understand?
Can we make one addendum?
What?
So the red line,
The red is the original curve.
the red line
This is P.
would be upside down because.
Oh, yes, okay, yes.
The only reason that's important is because the profit doesn't go up to infinity, like you don't.
In this particular model, yes.
If-
Because this is a negative, this parabola actually goes like this.
Yeah,
Yes.
so your profits slowly go down rather than.
Yeah,
shoot up.
let's say we go and we try and sell what was the limits I said between 2,400. So what would our derivative be at 2,000? So we're like, hey, we're going to really crank out a bunch of car seats now, right? Let's just really figure out where we're getting the most, let's just sell all these car seats. What would the derivative be at 2,000? So someone plugs 2,000 into this, right?
Negative 55.
Negative 55, crap. So what's happening is our profit function is dropping, right? So I'm glad you brought this up because this is actually going to be important as we proceed. The original function looked more like this, right? So what do you think, if I'm sitting down in that boardroom, the most important point on that function is? The highest point, right? Because, I'm greedy, right? I want money. So I want to know right there, because I need to sell a certain number of car seats so that I get the maximum profit, right? Maximum profit. Yeah, you agree? So I think this might really illustrate, and I'm getting a little ahead of us, but you brought it up and it was a very good point, is that could you actually find that point? How? No formulas. Can't use a vertex formula. I want you to think about this. I would like to know what number of car seats I need to sell to find that highest point.
Couldn't you just plug in the derivative?
Kind of. Keep going. It has to do with the derivative, but how do we use the derivative? And let me put the derivative back up here. The derivative of this function was 45 minus 0.05x, right? This represents the slope of the tangent line at any value of x, right? You give me 800, it was 5. You give me 850, it was 2.75. You give me 2,000, it's like negative whatever it was, 50 or 55. What, if I want to know this maximum profit? Then I'm trying to find that tangent line, right? What's the slope of that tangent line? That's 0, isn't it? So isn't this really asking if you're sitting down in the boardroom and you're like, hey, ladies and gentlemen, see how politically correct I am? Ladies and gentlemen, I don't even know. Okay.
Now some places take advantage, you have to call persons.
Okay, so look, yeah, I'm just going to go away from that. Say I'm sitting down in the boardroom and I'm talking to my colleagues and I'm trying to figure out where the maximum profit is. One of my employees who understands how